I need to figure this out.
What's the problem?
12 seconds later.
So I got all this stuff, and all my photos and documents are on there, and these devices and hard drive, and I kind of just want to put it all in one place, you know?
Ah, you need the cloud.
Yeah, okay, the cloud. What does that do?
Well, it's like this thing where I can put all your stuff into one place for 6 months.
So what happens after 6 months?
The river.
What's the river?
The river's just like the cloud, but it's in a completely separate place, and they're not compatible. So if you were to try to move something from the cloud to the river, the file would be instantly destroyed, and your keyboard would be really hot.
Yeah, so I don't want that.
I tried the river.
And?
Yeah.
Yes?
Yeah.
What?
Well, there's still a few bugs in it.
Listen, I just need somewhere to store all of my files and photos in a permanent place. Can you help me with that?
Are you familiar with the concept of
1 minute, 37 seconds later.
entropy?
Entropy? What's entropy?
Oh, I'll show you. I'll show you. Who wrote this, dude? What is this? Get this big arrow energy out of here.
It's probably that kid Raph again.
One extremely annoying shift later.
Entropy is described by the second law of thermodynamics.
And what does the second law say?
Well, the second law states that the total entropy of an isolated system can never decrease over time.
So are there different ways to describe entropy?
Well, there is thermodynamic entropy.
And how do you describe thermodynamic entropy?
Well, it can be expressed by the equation
Can you explain that equation a little bit more?
Well, to get the difference in entropy between any two states of a system, we find a reversible path between them. And integrate the energy supplied as heat at each step.
A lot of boring math later.
And then divide by temperature.
So that's thermodynamic entropy. Are there any other ways to describe entropy?
Well, there is a statistical definition of entropy.
Okay, so there's a statistical definition. Is there like an equation or something for that? Can you describe it a little bit more?
Well, we have the Boltzmann formula. Where K is a constant and W is the number of microstates.
Microstates. What are those?
It could be defined as the number of ways the molecules of a system can be arranged.
Yeah. Okay, so if like the number of microstates in a system was 1, then the entropy would be 0. That makes sense. Wait, dude. Come here. Look at this.
Oh.
You know that Boltzmann guy?
Yeah.
They're identical.
Oh, I know what to do.
So, if I'm reading this right, the Boltzmann formula lets you capture the absolute value of S in a system.
Absolutely, yes.
So, what if a system is isolated from its surroundings? Wouldn't the change in heat be 0? How would you describe entropy then?
Well, it is described by the Clausius inequality.
Oh, okay, that makes sense. When Q equals 0, then ds has to be greater than or equal to 0. So that means that the change in entropy can never be less than 0 in a spontaneous change. Okay, that makes sense.
See, didn't I say this was great?
Yeah, man, that actually really helped clear things up about entropy. Oh my god.
Wait, what's going on? What?
You don't see it?
See what?
Look again.
I don't see anything, man.
You want to give me the pen?